Okay, so let's get started. Um, let's share this. Please, guys, confirm if you can see my screen. Can you guys see my screen?
Yes, yes.
Okay, so yeah, okay, yeah, screen off. Yeah, so I was told that we should go through data structures again. Um, what happened was that the last time I met you guys, please, if in any time you can't hear me, just draw my attention. Okay, you can talk. You can just unmute and then talk because I'm a little bit away from the chat. I might not see the chat, so you can unmute and then talk at any point in time if you can't hear me, please. So we are going to go through data structures again. I don't know how many of you were there in our last class, but there was a challenge, and then um, I don't know what actually happened, so I wasn't able to the audio and then the video were far away from each other. So let's get started. So we talk about, okay, let's just go straight forward. So data structures are a way of organizing and then storing data. So I told you guys that for instance, let's say you are in your room. So I'm going to use, yeah, you are in your room, and then you have baskets in your room, and then inside this basket you keep one of the baskets, you keep your dirty clothes in it. In another basket you keep your clean clothes in it. In another basket you put your shoes. I don't know if people keep their shoes in baskets though, but let's say that's what you do. So data structures, the basket in this scenario is what is.
Hello? Hello?
Yeah, Ken.
Can you hear me? Can you hear
Yeah,
me?
yeah, I can hear you.
Okay, sorry for interrupting. But I was wondering, is it because of the last recording that you want to go back to data structure? Because I think we've had like two separate classes on that, if I'm not mistaken.
Yeah, so Tanaka told me that it is the data structures that I should take them through. That was what he said. That's what he was going to take them through today. I don't know if that's so I should take them through data structures today. That's what he said. Let me.
Uh,
Can you guys confirm
can
where
you?
you've gotten to so that I can maybe know where to proceed?
I was wondering, like, maybe you can hear from the
Were you
participants,
with
right?
them in the last class, by the way?
Yes, I was in the last class, and was it not? I think that was the notebook that you presented,
Your
right?
Ken, your voice is a little behind.
Can you hear me?
Yeah, I think I can hear you now.
Hello? Can you hear me?
Yeah, yeah.
Okay, so I wanted to say if you can hear from participants, right? And those that were in the last
Are
class, but
you?
I think was it
Is
not
there
data
earpiece
structure that
in your device?
no, I am not unfortunately. But can you hear me as well?
It's I think it's clear now.
Okay, so what I was saying is you know, can we like hear from the participants, those
Yeah,
that were in the maybe so that we don't maybe keep repeating the same thing? Because I think if I'm not mistaken, it was the data structure was covered in that last class. Can someone unmute and talk, maybe to represent the
yeah.
other participants?
I think Dema is here. If Dema is here, if she could talk about that. Prince, I don't know. Those of you who were in the last class, I just want to know if data structures were covered so that we don't really keep repeating. Because what Tanaka told me was that I should take data structures again. That was what he said. So if you guys were there and then it's been covered already, so that we don't really keep repeating everything over and over again, we will just go straight forward and go to the next
Yes,
session.
that's
Yeah. So I want to
because
know from you guys if you guys
what
can just.
yeah. So what we want to confirm now is whether those that were there on that Wednesday are still the same people there. If they are the same people there, we can move on to something else. Then we can forget about the recording. The recording is not the ultimate thing. You get my point. So instead of keeping them again to see discuss data structure, right? Then we can move ahead. Right? But if there are different groups, right? Maybe those that were here that last time were not are not the same people here. Maybe someone can unmute and speak for the rest.
Yeah. So guys, if you were here last time, you can just unmute and let us know so that we move past this. Anyone? Okay. So Prince is saying that he wasn't in class last time. So if there is a recording of the last class, um, Ken, did you guys record the last class? Like, is the recording available?
Well, to the best of my knowledge, he recorded it, but I don't know if it was okay because he recorded with GC and of course GC has its own limitations, so that could be an issue. Maybe the recording did not save as expected or something like that.
Okay. He hasn't, cause what
So maybe
we
someone else,
oh,
someone I think was it friends that said he wasn't here in the last class, right? Can two
yeah.
other persons confirm this? We are doing this for you, so please can you unmute and then
Yeah, or you can just
let us
type in
know.
the chat, yeah, so that we confirm that and then we can move on.
Okay, hi guys. I wasn't on the last class, like on the Wednesday class, so I don't know what happened there. So that's why I joined this one. So I'm not sure what's going to happen there.
Yes, I think
I
about three
wasn't
persons
on
have
the
confirmed that they were.
yeah.
All right, that means we can proceed with data structure and then have the rest of it.
Okay, so them are right. Is that a pronunciation of your name?
Yes, yes, it is. So basically, I've been following your classes on where we left off. So I don't know what had happened on Wednesday.
Okay, okay, then that's cool. So okay, let me just okay, so let's just go through the data structures once more, okay?
All right, all right. So then I think maybe you would have to start the recording again so that we don't capture all the
Honestly,
things
honestly, the
we were saying.
recording
So
is on.
sorry
Seriously,
for that.
the recording is on. Maybe
All
when
right.
when I send it, we'll just cut out past that, but apart out. Okay, so I did stop recording, so it's still recording. So let's go. Let's go. Okay, so let me share my screen again, and then we do this. Okay, so let's share this. Okay, and also the WhatsApp link. Okay, don't worry, we'll share everything when we. So guys, confirm if you can see my screen. I know it is showing this endless something. Is my notebook showing, please?
Yes.
Okay, yes, good, great, great. Okay, so let's go. So I'm starting again. So still talking about data structures. So we talk about I think I was giving the example about you having your clothes, the dirty ones and then the clean ones and then probably your shoes and then or let's say you have this. box where you put your shoes in it and all of those things. So that is what data structures are. So they are just containers, and then you put a given a type of data into it, because the clothes scenario that I'm giving, you'll be able to see that you won't be mixing your dirty clothes with your clean clothes. You won't be mixing your shoes with your clothes, maybe in the same box or whatsoever it is. So that is what data structures. That is the idea about data structures that you guys need to be aware of as we move on. So we have what we call vectors. So in R, the dimension of a data structure determines we are able to understand the data structure by its dimensions, and then the type of data it can keep. So for vectors, which we'll be going through, it's a one-dimensional data structure, and it can only keep same type of data. So it can only keep a particular type of data. So if we are taking the clothes scenario, if you have one basket that contains your clothes, you can't put shoes in that. You can't put maybe plates in that, or maybe you can't put your books in that. So it can only contain one type of data. Then we have the next one is called list. So list is also one dimensional, but for list it can take a mixed type of data types. So you can put any type of data into a list. We also have matrix, which is a two-dimensional data structure. It could be two, it could be three. It's I'm sorry, two-dimensional. Yeah, we'll talk about that when we get there. It also contains same data type, so it has the data type that it contains can only be this one particular data type. You can't mix float, you can't mix okay, we talk about numbers, we talk about characters. You can't mix them up in a matrix. So that is what the same data type means. We also have data frame. A data frame is a two-dimensional, which meaning that when we talk about two-dimensional, let me say this first before we go. Two-dimensional means that it's made up of rows and columns. So I have my whiteboard here. I hope you guys can see that. So what we mean by two-dimensional means we have rows and then we have columns. So this, when you are going down like this, it is column, and then when you are going in this direction, that is what row. So anytime you have a data type that is made up of rows and column, we call it two-dimensional data type. That is in R. So it's very important for us to understand this, because most of the work that we'll be doing, because we'll be going into data manipulations. We'll be going into data where we'll be importing data, and then we'll be analyzing the data. We'll be making use of the data. Now, data frame is very, very important, because the data sets that are going to come, they are mostly in the form of data frames. And then knowing how to construct a data frame, what you can do to a data frame, how you can manipulate that data frame is very, very important as we move on. So this is something that is very important for us to understand as we go. If you guys are still following, let me know before we go into vectors. Everyone is following, right? I need your feedback. Okay, do I
Yes,
have
yes,
some
yes.
yeses? Yeah, following. Great, perfect. So let's start with the first one, which is vectors. So I told you guys that vectors is one dimensional. So it is just a sequence of elements. And like I said, they should be of the same data type. That they could be numeric, they could be characters, they could be logical values. So honestly, vectors are just the simplest data structures in R. I want you guys to, like I said from the first class, my analogies are mostly going to be biased, because we've mostly been doing this because of the program that we are doing, but this is going to span more than that. But you guys should hold on to these examples that I'll be giving. So take vectors as like a row of test tubes. Now, inside these are test tubes. I don't know, those of you who come from the chemistry side, you would be able to understand that. So you have test tubes, and then inside this test tube, you put like water into it, you put like HCl into it, you put like NaOH into it, you put like an ester into it, and all of those things. So that that is what data structure is. It can only contain a particular type. That is what a vector is. Sorry, it can only contain a particular type of data. Getting back to the dirty clothes and then the basket example that was given, analogy that was given, if you have a basket and then the basket, so basket example for vector is that the basket can only contain clean clothes, nothing else. You can't put shoes into it, you can't put dirty clothes into it. That is what a vector is. So we create a vector using this symbol, this letter C, and C there refers to combine. Please, if you come on and you want to ask a question, you can ask. If you don't have a question, you can just leave. Okay, so let's go. So this is, so we have we create a vector using this symbol, like I said, the C symbol. C symbol means combine. So what it means is that we are just combining these variables, or these items that we have. So this is a vector that is made up of genes, is made up of characters, because that this gene is made up of characters. We have expression level. So expression level, that is gene expression level, which is made up of what? Numbers, or yeah, or numeric characters. I'm sorry, numeric values. Then we have statuses, which is made up of um, logical values. So you have true, false, true. Then we came across this last time because I told you guys that this can be used to check the data type of a particular variable. So if we run this, we want to check the status, that is the class of statuses. So if you check it, you can see that this is what a logical variable. If we also do the same thing, if you check of um, the class of genes, you would also see that this is going to tell us it is characters. So this is what I want you guys to understand, that vectors contain only one type of what data type. But then there is also a caveat here. The caveat is that you can create a vector that contains different data types. It will still work. It's not going to give you an error. But the only thing is that it is going to convert the values in that vector into an depending on the type of variables that are inside your vector, it will now convert them to a part to one type of data type. So what do I mean with this? So the one type of data type is going to convert them is that it mostly takes precedence. So it takes precedence by taking into consideration characters first. So if you have a character in your um, vector, it is going to convert all of the the vectors to all of the vectors to a character type. So here I we have false. Let me use capital caps so that we see what I mean here. So we have false here, then we have true. So this false, when we talk about variables, we say that if you bring this quotation sign, it means that you are saying that should be what a character data variable, or a variable. So false, and then we have true here, which is a logical value. We also have 2.6 here, which is a numeric value. Now, if we should run this here, you'd be able to see that it is telling us that okay, this is all of these are character values, and then we have what the type of is telling us that this is what a character. Now let's say I am taking this false off, of this character off, and then I run this. Let's look at what comes out. So you see that this is telling us that this is a double. So you can say that it is converting the false to a double variable. So you can see that this is false has turned to 0.0, this true has turned to 1.0, and I don't know if you guys remember, but I think yeah, Ken mentioned this in Python that false is 0 and then true is 1. Yeah, so this is mostly um is there anyone asking a question? Okay, let's move on. So this
Yes,
is
I'm not sure if everybody can see, but I can't see your screen.
you can't see my screen.
I think it's on your end because I can see it.
Um
Oh, then it's my side. Then can you just refresh? Okay.
Maybe you could rejoin and then.
yeah, so try
Okay.
and rejoin, let's see. Okay, can we move on? So
Yes.
okay, yeah, great. So here, you would also see that the double value is mostly giving precedence when there is when there are values in a vector that are not of the same data type. Assuming, let me just say that I put let's say 20 here. Let's look at what we're going to get also, because that still we're getting double here. But let me just take this 2.6 off and check this out, and then you will see that this is still giving us double. I told you guys about the fact that numbers numeric values in um, R could also be seen as double if we find if that is type of print numeric variables as the default data type. That type of print for numbers is double. We talked about this thing last time in the last class. Those of you who haven't really seen gone through that, the record this is on YouTube. You could just go through that and then you understand this concept. So here the false is converted to 0, and then the true is converted to 1, and then the 20. So this is giving us what a numeric value. So this is very important. I want you guys to take note of this because um you'll be working with some data, and then you have true false and then some numbers in it, and then when you begin to analyze the 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 data, you are getting some numbers instead of the true false that you're supposed to get. So this might be what is happening. So you need to understand these concepts before we move on. So now that we understand what very vectors is, how we can create a vector, and then when a vector is not having the same data type, what happens? Let's move on to how we can manipulate vectors. So we can manipulate vectors by one, using what we call disposition value. So to be able to access a value in a vector, you use this square bracket. So we are taking a gene. So the genes that we define here. So let me just bring this here. So we define this gene here, and now we want to take the second value. In R, R doesn't do R count from 1. So if we have something like this in R, let me clean this. So in R, when you have let's say so you have a vector. So let me say vec here, and then inside this vector we have I'm just using this example. Let's say we have tall, we have big, and then let's say we have 1 here. So here what happens that this is going to be set to position 1, this is going to be set to position 2, this is going to be set to position 3. So in Python, this will be index 0, index 1, and then this is going to be index 1, this is going to be index 2. This is in Python. But in R, we indexing starts from 1. So that is something that it's you need to know. You don't have to really worry much about indexing when it comes to R. It is only in Python that you have to start from 0. So that is something that you guys need to be aware of. So when we are using this square bracket is used to take a value. It's used to be able to access a value in a vector. So the 2 is telling us that okay, we want to take this second value. So this second value, that's what we are taking. So if you run this, you would be able to see that the second value is what is being printed out for us. Then when you see this, so let's go back to this again. Okay, sorry, here. And when you have a vector, okay, let me clean this, sorry. So when you have a vector and you want to access a range of values from that vector, this is what we can do. So you have the vector that we have in the code, which is a genes. So we are saying that we want to access genes, and then we want to, what do we have here? We have what, 1 comma 3 1, so dot 3. So now in R we use this dot to serve as a range. So you use it to be able to access range of values. So this is the starting position. So this is a starting position, and then this is the ending position. So it means that we want to access the values in this gene starting from 1, that is the first position, and then going to the third position. Like I said, R starts from 1, so it means that it's going to take the first value, then the next value after 1, that is going to be 2, then the next value after 2, which is what, 3, and it is ending on 3. So that is it. Assuming that we have, let's say, more than let's say we put 5 here, so the same thing. So it's going to start from 1, go to 2, go to 3, go to 4, and then end on what, 5. So it will start from 1, then pick all the range of values in there till it ends on what, 5. So if we get back to this place, you'll be able to understand that genes 1 um, column 3, this column, like I said, from in the write-up, is what is showing us range. So we are starting from 1 and then we are ending on 3. So that is what this stands for. Then um, when you use this sign, exclamation mark is equal to, so what we are saying is that okay, we want to pick genes, but then we don't want to pick, we want to sort, we want to take this one out. So genes not equal to, so anytime you see this exclamation mark equal to, it means not. It is also the same thing in Python. So anytime you see exclamation mark, it means not. So we want to go through these genes here, and then look for, we want to pick all the values that are in this gene that are not TP53. So that one, you can see that is what is giving us here. So we have this is equal to TP53. So it's not going to pick that, and it's going to pick this, and it's going to pick that. So that is what this does. Then another way we can do this, is using this negative assignment or negative value. In R, anytime you assign a negative value to something, means that you don't want to pick that thing. So we have a range of values in genes, and then we are saying that we -2. This means that go through all the values in gene and then take out the value in the second position. So the negative means that it is taking out that value. So it will take out that value that is that position. So here the value in the second position is TP53. So it is going to take out this value, it's going to take this value out and then print the remaining value for us. Note that in Python, this -2 means that we will now come and start reading from here. So -1, and then from -1, then we come to -2. That is in Python. But in R, negative means we are taking out that value in that position. So that is how we can manipulate genes. Then we can also do some operations on vertices. Some of the operations we can do on vertices is that we can add numbers to it. So we can, when you look at a gene expression, let me go back here and copy our gene expression values here. And then when you come to this place, so we have our gene expression. Oh, so we have the gene expression value here, and then it's made up of what numeric values. So we want to be able to first of all do some arithmetic operations to it by adding 1 to each of the values. So if you look here, the first one is 2.5, so we added 1 to it, becoming 3.5. This is 3.2, we added 1, becoming 4.2, and then on and on. We can also do logical operations by checking, okay, is any of the which of the values is greater than 3. So here that 2.5 is less than 3, so it is giving us false. And then the next one is what, 3.2, which is greater than 3, so it is giving us true here. And then the 4.8, which is also greater than 3, so it's giving us true here. So we can perform logical operations on this. We can also provide some summary statistics on a vector. What we can do is that we can find mean, we can find the mode, we can find the length. So how long, how many values? The length means that how many values are in our gene variable. So you can see that we have 1, 2, 3. So okay, we have it's supposed to be 3. I don't know why they are giving us 4, or because we added something. Okay, I don't know why they are giving us 4 here though, but yeah, maybe. Okay, I don't know, but yeah, maybe I'll check this one out. I don't know why they are giving us 4 here though, but it's supposed to be 3 because we have 1, 2, 3 values in it. Yeah, so let's move on. Let's move on from here, and then we'll debug this later. Then the next thing is that we also have what we call named vectors. Named vectors means that we assign names to our values. So if you want to get an example like named expressions, so this is a gene, this is its expression value, this is a gene, this is its expression value, this is a gene, this is its expression value. So named vectors can be done by you giving the name and then assign it the value. The name assign it the value. So that is how vectors can be named. And then named vectors can also be accessed by accessing the name. So if you go back to this place, you can see that if you want to get the second position, the second item in this gene, you use the position variable. But here, because we've named it, you use its name to access its value. So that is what we use named positions for. Then the next thing we can also do is to order our we can order vectors. Vectors can be ordered. We can use the sort or the order function to do that. So we have our gene expressions here, and then we can sort them out. We can sort the values out from highest to lowest. So we have 2.5, 3.2, 4.8, and then we have what 1.5. So this is giving us 1.5 is coming first, so it is sorting it from in ascending order. Then the we can order the genes. Now this order function tells us the position of the values. So the least value here is what is 1.5, and it means that the 1.5 is in what, the fourth position. So it's in the fourth position. So if you look here, this is the fourth position. Then we now come to the next one. This is the next least value. So the next value that is after 1.5 is what 2.5, and it's in what the first position. And then it follows like that. So that is how this can be done. Now you can sort using the sort function, or you can also use this to do that. So expression level, and then you can order by the expression level. So you can combine the expression level, this sort function here, you can put it back into this expression level, and that is going to sort the values for you like the way you do sort. But sorry, I was talking about this. We use the order variable function. When you combine this order function, when you put it back into the expression level, we can sort it out. But mostly just use your sort, and then you'll be able to sort everything out without you really having to do this. But mostly this is mostly done um when we get to data types. So we'll talk more about this when we get to data types and how to use this there. So this is what we can do to vectorses. And I have some um video here as usual, and then I have some pop quiz for you guys. I don't know if I shared this in the chat group, by the way. Let me share this in the chat so that you guys can access it, or you guys have access to this already. Because the last time we met, I shared this with you guys. I don't know how many of you have it, but let me share this again so that those of you who are you guys are following, you can just follow up. So the quiz questions are in the notebook. You can check it out and then see if you can crack some of the codes in it. Yeah, Shigozi, we would try and then add you to the group. Okay, so for now, just let's finish the class and then we'll sort that one out for you. Okay, if that works for you. Um, guys, any questions? Any questions so far on vectors before we move on? So these are just some quick questions. Okay, so you have a vector called expression level, which is having this. How would you retrieve only the second and the fourth expression values? Just check this one out. I don't want us to really go through them. We could go through them, but just for us to be able to save some time, I have some videos for you guys also here, so you can check it out. And then some true or false values here. So for instance, you can store both these and these in the same vector without any changes to the data type. Is it true? So explain your answer and then spot the error here. What is wrong in this code? Then also have some challenges. So how would you extract the value of TP53 in this vector? So these are just some quiz questions that you guys can check it through. I sent the link to the notebook in the chat so you guys can access it. Those of you are on PCs, you can access it, and then yeah. So guys, any question before we move on to list? Any questions? Questions? Guys, I'm still waiting. Any questions? Any confusions? Or we should move on. I need your reactions. Hello? Is everyone following? Okay, Prince says we can move on.
Let's
Okay.
move on.
Okay, great, great, great. Thank you guys very much for the feedback. Okay, so it means that we are following. So let's move on to the next thing, and then we go. So let's share again, and then we get back to this. So the next thing we're going to talk about is what lists. Okay, so list is a collection of data elements that can be of different data types. So let's go back to the basket scenario. So in the basket scenario, we have guys, please hold on for me. Yes, Obi, you hear me? Um, okay. Uh, what is happening? Yeah. Guys, can you hear me? Guys, can you hear me? By the way, hello.
We
Uh,
can hear you.
okay. Please, I need you guys to give me just a second.
All right, all right. Can't hear you again. Oh, he said we should give him a seconds. Okay, thank you.
Yeah. Sorry for. Okay. I'm back now, guys. Can you hear me? Can you all hear me?
Yeah, we can hear you.
Yeah. Sorry. I had to attend to something quickly. Sorry for that. Okay. So let's share this back and this. Share this. Okay. So we are talking about a list. So lists, like I said, could contain different data types. Now, getting back to the clothes thing that I talked about. So you have your basket, and then inside this basket you have your shoes in it. You have your clothes in it. Maybe you can even put your books inside that basket. So that is what a list is. So a list is just like a combo meal where you have like protein, you have like drinks, you have desserts, you have everything inside that food inside that meal. So that is what a list is. Now we create list using uh, this keyword. So you type the keyword list and then you provide your values in it. So here we can create what we call a named list. So you have the name and then the value. You have the name and then the value. You have the name and then the value. Then this is you creating a list. And you can also create a list using what's the name? Using a vector. So we have this vector false, false, and then this, and then now we can create a list out of this vector that we have. Because I told you guys that we create a vector using this. So using the keyword, the C keyword, which is combine. So if you wrap a vector inside a list function, that creates a list for your value or variable for you. Sorry. Yeah. So this is one way we can create a list. This is also another way we can create a list. So we can create a list using the the name the a named list. We can also just go ahead and create a list using the vector. If you use the vector, it's not going to be a named list. It means that you have to now assign a name to it. So you probably have to now come and then assign a name to your list. So I'm not really going to, let's not really worry much about that for now. But the simplest method is just go straight, name your list, give the values that you are going to assign in a list, the names, straightforward, and then you go your way. So that is it. um the other thing is that here you guys can see that this list is made up of we have, this is a character, this is a double, this is what logical. So that is what this is going to tell us, that we understanding what I said here, that it contains what different data types here. So that is what lists do. I'm sorry, have, yeah. Then we can also manipulate lists by using this dollar sign. Using this dollar sign can we use a dollar sign to be able to pick the name that is inside the list. So if I have a list here, reconnecting, where's my eraser? If I have, okay, this is taking long to read. Oh, wait. Are you guys hearing me? Oh, I've been talking to myself all this while. Um, guys, confirm if you can hear me. Oh, okay. Um, okay. I'm back now. Something happened. We can move on. Okay, guys, confirm if you can hear me. Chigozi, confirm if you can hear me. Dema, confirm if you can hear me. I
Yes, yes, we can hear you.
okay. Okay, thank you.
We can we can hear you.
Okay, great. So let's share this.
We can actually hear you.
Yeah. Okay, thank you. Okay, so let's get back on track here. Can you guys see my screen?
Yeah, we can see your screen.
Okay, is the notebook showing?
Yes, it's now showing. Yes.
Okay, great. Thank you so much for the feedback. Okay, so let's get back to this. I was showing you guys this before I went off or something. So we can so let's say genes, okay? So genes, and then we can use this dollar sign. So let's just say name to be able to access the, so we created a list, okay? So these are lists, our list variable, and then this is what a name of a value that is inside this list. So using this dollar sign, we can use this dollar sign to be able to access the name that is inside our list. So this is what we can do in Python. For instance, when it comes to the data frames, you would see that if, let's say, you have a data frame called df, and then maybe inside df you have a column called, let's say, name. So if you do column dot name, you will be able to get the name column out. In R, when you are dealing with lists, when you use this dollar sign will be help you to be able to access the name of the variable that is inside the list that you created. So that is how we access values from a named list. Now, if you get back to this place, we can also, if you look here, we created the gene profile. You can also use this double whenever you want to access a value in a list, you use the double um, square brackets. Please take note of this because um, the square the double square bracket only access a value. So you bring so let's bring this gene back. So let's say we have the gene. We use double square brackets to access a value that is inside. So this here is supposed to be what? A value. It shouldn't be a name of a value. If you want to access the name, then you just go ahead and write. So let's say we have this, and then we have uh, a name in this gene called, let's say, name. So let me just use name here. So we use this to access the name. Either you use this or you use what I showed you guys earlier. So gene, and then you bring this dollar sign, and then you have your name here. So this is the same thing. You using this is the same thing as you using this. So these two things are the same. This is you accessing a name that is inside your gene. If you want to access a particular value, then you use the double square bracket. So this is how we access values in a list. This is how we access values in a list. This is how we access a name that is inside a list. So please take note of that because understanding these things are very, very important. So here we use these double square brackets. If you go back to lists, you would see, sorry, if you go back to um, vectors, you see that we just use one square bracket here, just one square bracket. But if you come to list, you use double square bracket to get a particular value out. But then you use, if you, I think I have explained this one also. So we have like gene profile and then the name that we assign here. So if you get back to this place, we have status, we have expression, we have gene. So this gene, the value is this expression, this is value, this status, this is its value. So if you take status, the value of the status is what is true. So that is what is happening here. But then the only difference between you using this and then you using this is that it is going to return the name of the name of the value, and then the value itself, it is equal to that the name of the value that has been assigned to it. And the reason why we use this dollar sign is because arrow mostly represents of the names in the list using this dollar sign. So if you want to just access this value straight, the value of status straight away, that is when you use this. So instead of we doing this, we can just do the gene profile here. So gene profile, and then we bring the dollar sign, and then we can get the status. You can see how we have status here. If you run this, you will see that it is going to give you what the value true. But if you are using this, it is just going to give you the name of the state of the variable and then the value that was assigned to it. So this is how we can access and manipulate values in a list. Then we can also do some operations on a list. We can append new values to it. So appending new values to it is just by you assigning a new name. So you will bring this dollar sign and then you give a new name. You can assign then its value to it, and then you can also do add some modify. So you can modify the elements that are in a list by, for instance, when we come back to this here, we have the gene expression here, which is 2.5 here. We are adding one value to it here, and then if you run this again, we'll be able to see that we have gene here, we have expression here, we have the expression value here. We have the status which is true, but then a new value was a new value was created, which is called category, having this value called tumor tensor suppressor, sorry, as we have here. So this is what we can these are some of the things that we can do to a list. We can also do looping. We can also loop through values in a list. When we get to the loops, we will talk more about that when we get there. Now, list can be named, yes. When each of the values in the list can be named, but then list cannot be ordered. The reason why they cannot be ordered is because they don't have the same variable type data type. Sorry, they don't have the same data type. So if you come to list, we can you can have a logical value in it. You can have a, a, a numeric value in it. You can have a double value in it. You can any value at all you can have in a list. So because of that, you can't order it. So that is something that you need to understand when it comes to list. Here too, I have some jokes. I have some pop-up quiz. I'm sorry, some pop quiz for you guys. You can just true or false. A list in arrow can contain a vector matrix or another list. Is it true? Then you ask why. What happens if you try to run this? We can check that one. You can just run this on your own. Will it work? And if not, why not? Now there is also a challenge here. Create a list called sample one containing these values, then extract the second expression level. So this is how we do this is everything about list here. If you guys are clear with it, let me know before we move on to the next data type, which is matrix. So another question time. Guys, question time. Stop sharing this. Yeah, guys, question time. Or we can move on as usual. Are you guys here?
Yeah, we are here.
Okay. Yeah. Okay. So let's. Okay. Great. 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 Perfect. So let's move on. So let's continue to the next thing, and that is going to be. So my screen is showing still. Perfect. So matrix. So let's talk about matrix. Matrices. So sorry. A matrix is a two-dimensional rectangular structure containing elements of the same data type. So the reason why we say that it is two-dimensional data structure, I think I said this earlier, because it contains what rows and columns. So a matrix is, those of you come from the math background, you would be able to remember this, that we have, let's say, 1, 2, and 3. So we have 4, 5, and what, 6. So if you are looking at the values from this side, this is what we call row. If you are looking at the values from this side, so this side like this is called column. So this is how matrices are are mostly created. So a matrix is made up of, is rectangular in the sense that we have rows here and then we have what, columns here. So that is what makes it a matrix. Yeah, and it could, the dimensions could be, the number of rows and the number of columns could be infinity. It could be an infinite number of rows. It could be an infinite number of columns. So that is what that one is. As we move on, so let's just look at them. So um, all elements in a matrix can be, should be, and must be either numeric values, there must be logical values or there must be logical values. They must only be of the same data type. You can't have multiple data types in a matrix. So it is a two-dimensional data structure which contains the same type of data. You can't use any data type, a different data type for it. Like example of a DNA microarray, um, mostly the same type of values that are in it. So how do we create a matrix? We create a matrix using the keyword matrix or the matrix function. So you use the matrix and then you pass in the values that you want to use. So we have our matrix here, and then the n row. So one this I think we came across this, and I told you guys that anytime you're having one dot dot, that is semicolon. Is this semicolon or column? Yeah, column. This means that we want to take values from 1, starting from 1 to what? To 6. So we start from 1, 2, 3, 4, 5, 6. So this is what this means in R. So we want to take values from 1 to 6, and then we want to arrange it by number of what? Rows. How many rows do we want? We want 2 rows, and I want 3 columns. So if we get back to this place, we want how many rows? You can see that here we have 2 rows. So row 1, so R1, and then we have what? R2. And then we want to have 3 columns. So C1, C2, and then what? C3. So you define a matrix by telling it the number of rows you want and then the number of columns you want. So that is something that you need to take note of. Oh, sorry. Okay, yeah, we are here. Then when we come to, okay, or you can also have a named list. So we a named columns, named matrix, sorry. So you have genes and then samples. So these are just vectors that we are defining, and then now we assign these vectors to using okay, so let's explain what is happening. Let me explain what is happening here. That we have defined this matrix here. Okay, I'll define this matrix here. Yeah, let's use this one other. So we have genes, and then we have samples. We have these vectors that we created here, and then we created experiments matrix. This experiment matrix contains values, these values, and then we want to have order it by, we want to have 2 rows, and then by row, this by row means that, let me print out, let me run this and print this out for you guys so that I'll show you guys what we mean by rows. By row means that the values that you are seeing here, because we have 2.1, we have 3.5, we have what? 4.0. We want to have 2 rows. So it means that it will, first row is going to take this, the first value, the second value, the third value. And because we want to have 2 rows and there are 6 values in here, the values will now spill over to the next row. Now, if you don't specify by row and then you just give it to the by row to be true, and it just goes straight ahead. So let's experiment that here. So I'm going to use this as an example for you guys here. So here, and then we have a math here. So let's see what we get. So here we have one. So you said we have 1, 2, 3, 4, 5, 6. I want you guys to take note of this. Now let's look at this. The same thing that we have. So let's say matrix 2, yeah, here, and then instead of n call, let's just change this and say that, okay, so by row, and then equals to true here, and let's print out our math. matrix 2 here. Hey, matrix 2, matrix 2. Okay, so let's run this. And I want you guys to see the difference here. So you can see that here we didn't specify the number of rows here. Sorry, we didn't specify. Yeah, we here we specify the number of columns. Now we didn't specify that we want to arrange the values by row. So it took the first value, 1 here, and then went down to second row, then came to the top to give us 3, came down to 4, went to 5, came down to 6. But if we set the by row to true, what is going to happen is that it is now going to take the values and then assign those values to take the first value, give it go to the next value, go to the third value, and because we have 6 values in it, it is now going to spill the values over to the next row. So that is what by row does. Now we can also do by call here. So by call, and then let's see what this one also gives us. Um, oh, okay, wait. Um, and call as two. Wait. Sorry, guys. I think yeah, we don't have. You can't do by call here. There's no by call is not an argument in this. Sorry, guys. So by row here, we have by row. So you can only do by row. Sorry, don't. There is nothing like by call. Yeah. So this is one thing that we can do. Let's change this to and call and see what we get here. So if you arrange this by number of columns, you see that we've specified that we want 2 columns, and they want to arrange it by what? By row. So okay, if we so sorry guys, so by row can be set to true or false. If you set it to false, it means that we want to arrange by call. So that is something I should have said. Sorry about that. So we now want to now arrange these values that we have by columns. So first value goes to the first column, second value goes to the second column, then the next values go, and it goes until we are done. Now, what happens if your columns are not of a value that is divisible by 2? So let's say I put 9 here. So it means that we are going to be having values from 1 to 9. Now, like I said, 2 is, if you divide 2 by 9, there is going to be a remainder. So it means that our columns are going to be from 1, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, then 9. Let's see what happens. What happens here is that it is going to Arrow is going to tell you that there is a warning here. Why? Because 2 is not a multiple of 9, because the last value here is supposed to be 9, and 2 is not a multiple of 9. And because 2 is not a multiple of 9, because since 2 is not a multiple of 9, what will happen is that it's going to give 5 rows. So here it automatically give added some 1 value here. So you can see that it is we having 1, 2, 3, 4, 5, 6, 7, 8, 9, but then arrow gives you some 1 value here. What happens if you change this to um n row is that, so let's try that one to out so that I can use that to explain to you guys. What happens if you change it to by call to the same thing? So it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and because 2 is not a multiple of 9, it's going to assign 1 back to this. So this is mostly what happens. Now, if you change this by row to end call, so end call here, and then we change this to 3, let's also see what happens in this case. What will happen is that because the 2, now it is going to have from 1 to 9, right? From 1 to 9, but we want to have 3 columns. So these are the first value will be 1. So 2, then it goes to 3, 4, 5, 6. The next one is supposed to be what? 7, 8, then 9. Now there will be no value at the end for the column. So what R does is that it takes just a multiple of, it will just multiply the 2 by this 3, which is going to give you 6, and it gives you those values. So it's just going to give you 6 values out of the 9 values that you want. Making sure that you guys understand this concept, because sometimes you might be doing some analysis and then some values are off, and then you'll be asking yourself, or sometimes you'll be entering some values, maybe some metrics values, and then some values are off, and then you'll be asking yourself, "Well, like, what happened?" Sometimes it could be because you define a matrix, and then inside that matrix you the number of columns and the number of rows and the columns that you define were not really multiples of the values that you were given. So this is something that you need to take note of when it comes to that. So I hope we are following here. I think there is we still on. So that is that. Then the next thing is, yeah, I think have shown you guys this. We have also shown you guys this. We can also manipulate metrics. So let's understand this. When it comes to matrix, um how do we assess the values in a matrix? So let's look at this. So you have a matrix. So let's say we have this matrix called math. Okay. Now in a matrix, if we have this and comma this and comma, let's say 3, what this means is that the first value here, anytime you see comma in a matrix, or let's say, yeah, whenever you are dealing with matrix or you are dealing with a data frame, and then you see this comma, the first value stand for row, and then the value after the comma stand for what? Column. So what this means is that we want to go to the first row and then the third column. What is the value that is there? So if you get back to this, 1 comma 2 means that, let me bring this matrix back to this place. uh, okay. um yeah, so let me bring this matrix back here. So we have this matrix here. We have this matrix which you define here. Now this is first row, this is first row here, this is the second column. So these are second column. Now what this is telling us that we want to take first the first row, and then what, the second column, the value in the first row and the second column. If you get back to this place, like I said, so the 1, we have 2 here, so let me put 2 here. So we have 2 here. So let me just draw some matrix somewhere here. So we have a matrix 1, 2, 3, 4, 5, and what, 6. So in this matrix, what will happen here is that we want to go to the first row. So this is our row 1, and then this is this column 1, called 2, and then called 3. So you want to go to this is row 2. So we want to go to row 1. So the first value here is row 1. So row 1, all the values that are in this row are in row 1. And then we want to go to column 2. So all the values that are here are in column 2. Now where this is going to meet, the value there is what we want to take. So that is what matrix 1 comma 2 stands for. So we get back to this place, and then we want to take row 1 column 2. So this is row 1, so this is the values here, and then column 2, so we want to pick this value that is here. So if you should run this, you see that it is giving us what, 3.5, because the value in that position is what, 3.5. So that is what this means. Then anytime you don't bring any value, anytime you come to a matrix, so I have this matrix here, and then I bring comma and then 2. what this means is that there is no value here. So if there is no value here, what this empty space stands for is what? All. So it means that you want to take all, we know that first position is what? Row, right? So you want to take all the rows, that all the row values, and then that are in what? Column 2. So if we get back to this place, and then if you look at this, this is what? The all the rows, all these rows. So this is giving us what? All the rows that are in here. So the experiment, you can say that this is comma. So it is taking all the rows, all the row values. So we can say that S1 is here, and then all the values that are inside that is what is, all the rows that are inside is what is giving us. Is giving us the, sorry, what was I saying? Here. So we are taking all the rows. So this S1 row, S1, this row, S2, and then it is taking this column. So where is this column? Yes, this column. So it is taking this, it will come to this row, pick this value because it is picking all the row values. So it will come and pick this value, then come to S2 because this is row 2, and then come and pick this value because we are picking all the rows that are inside here. So that is what this stands for. Then we can, if you pick row 1, you can also add here, it is telling us that okay, it is picking row 1, this row 1, this is row 1, and then adding 0.5 to all the values that are on that row. So if you look here, this one, the value here was what is 2.1, but if we add 0.5 to it, we added 0.5 to it, becomes what? 2.6. So that is what you are seeing here. So this 2.1 here, add 0.5 to it, becomes 2.6. This is 2.5, add 0.5 becomes 4. This is 4, add 0.5 to it and becomes 4.5. So this is how you can manipulate matrices. Then we can, there are some operations that you can do on matrices. You can transpose a matrix using the T function. So T transpose. Transpose means that if we come back to this place, we have this matrix which is, we have 1, 2, 3, 4, 5, 6. Transposing it means that we want to now turn it upside down. So instead of, the rows now become columns, and then the columns now become rows. So we'll now be having something like 1, 4. If you guys look here, we're having 1, 1, 2, 3, 4, 5, 6. And then, so if you are transposing it, it means that will now be have, this now becomes columns. So these rows now become columns. So we'll be having 1, 4, then 2, and then 5, and then 3, and what, 6. So this is how we transpose this matrix to this, into rows and what, and columns. So if we have our matrix here, if you guys look here, we have in S1 and then what, S2. If we transpose it, if you see the T using the transpose, we can, what will happen is that it is going to now change it to this. So you can say S1, S2. So S1 here, which was a column, a row, sorry, has now become a column. So the S1 and then the S2 has now become a column, whilst the BCA, the TP55, and then these ones now became rows. Then we could also do some simple operations by adding 1 to all values that are in the matrix. So we can add 1 to each of the values that are in this matrix, and that can also work out. Now, can matrix be ordered? Yes. Why? We can order matrix using what we call the row name and then the call name, because if we get back to this place, I think I didn't mention that, but we could assign names to the rows, the matrix. So here we had genes, we had samples, and then we just defined this matrix here. We having these values that we've assigned to the matrix. We order them by rows, and then the number of rows, 2 rows, and then by rows. Then we assign genes. Row name is what? The sample. So it means that because we have 2 rows, so we have 2 values here for the row, for the rows, and then we use call names, sorry, to assign the column names to what? To the matrix values that we have. So that is what we can do here. So we can also from here you can sort them out, or you can order them. Then here I have some jokes which I don't know if you guys to be interested in them. We also have some multiple choice questions here that you can check through. We also have some strategies, create a matrix for ESP with two rows and then three columns. Fill the values from 1 to 6. Set the row name to these and then this and that. So some videos also here, and then this is an example. You have a matrix like this, and then if you do TM, if you transpose it, what is going to look like? So what is going to be its output? So this is for matrices. Yep. Um, another break, and then we go to data frames. So guys, let me know if you guys are following me up to this point. Any questions, any confusions, any problems? Can vectors and matrices be combined? Um, yes, they can be combined, Dema. We did one here by having a vector here. So here is a vector. So here is a vector, and then we put that vector
Yeah, we are with
into
you.
a matrix. Oh, okay, great. So we have a vector here, and then we put that vector into the matrix. I hope that is what you asked, Dema. Yeah.
Yes, yes, that's what I asked. But yeah, that
Okay.
I asked us before you went there. So yeah,
Oh, okay,
thank you for
okay,
clarifying.
great, 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 perfect. So I think are we all cool so that we move on? Are we all okay so that we move on, guys? So that we finish with data frames, and then we can um call it a day for today, and then we go to the next thing the next time. Guys, are we all cool so that we move on?
Let's move on.
Okay, okay, great. So let's move on to the next thing. The next thing is going to be data frames. So please, I want you guys to listen attentively, because most of the real world data sets that we're going to be making use of, like in bioinformatics and anywhere that you are, the data frames that you're going to be making use of are going to mostly be the data sets, sorry, that you're going to be making use of are going to be in data frames. So knowing and understanding data frames is very important. Okay, so we create data frame using the data dot frame function. Take note, we create vectors using the C, which is the combined the C. So let's just say C. So there we go. Using the C function, we create list using the list function. We create matrices or matrix. That word is it matrices or matrix? Okay, whichever any of them. Let's move on. So we create matrices using the matrix function, and then we create data frames using the data dot frame function. So using the data dot frame function, we anytime I think we are familiar with this now, because anytime you bring the name and then you assign some values to it, that means that you want to create a named data type, a named data frame. If it's a data frame, if it is matrix you want, or whatsoever it is. So this is a named data frame. So we have genes, you have gene expression, we have what resistance, and then we have these values in it. First of all, I think I didn't say this, but data frames is it's having a tabular structure, and then just like a matrix though, but for that it's mostly accept mixed data types in 8 columns. So it has here we have these character values. So we have these character values, and then we have these double values, and we have these logical values. So that is are mostly how we can create a data frame. And then let's look at our data frame here. One thing I want you guys to understand when it comes to R is that R is very, very intelligent. Yeah, I would say that R is very intelligent when it comes to data frame than in pandas, because pandas would not tell you the data types of your variables of your columns until you ask of it. But R is automatically going to tell you what data types are inside your data frame, or yeah, your data frame. So here the CHR is telling us that okay, these are characters, these are characters, these are double, and then these are what logical values. So that is one interesting thing about data frames in R that you can take note of. So we can understand we now understand this. Now let's look at how we can manipulate data frames. We can manipulate data frames by using this assignment. We talk about this dollar sign. So we want to take all the values in the expressions. So if you do this, if you do data frame and then you bring the dollar sign, what you want to say is that okay, I want to get the values in the expression column. So you run this and then you can start. We have the expression column. So these are expression columns. We want to pick all the values that are in this column. So that is what this dollar sign means. Then we can also assess the column just like matrices. Like I told you guys, in matrices we have um, the first value. Anytime you are doing something like this, the first value here stands for what the column, sorry, the row, and then this is the column name. So if we run this is telling us that okay, we want to take the first value, the first row, and then the value in the gene column. This is the same as gene is in what, second column, right? So if we should do this, if we should do this, and then instead of this one, we put 2 here. Let's see what happens here. We run this, and like I said, it is giving it the same value. Why? Because if we go back to when I was talking about matrices, I told you guys that in matrices we can, first value is for rows and the second value is for columns. It's the same thing when it comes to data frame. So in data frame, anytime you get a first value, so 1 comma 2, let me clean this, so clean this. 1 comma 2 is telling us that okay, first row, row 1. Yeah. Please, is anyone asking a question? Is anyone asking a question, please? Okay. So data frame to the same thing. So we have our data frame here. So our df here. So the same thing. This is the row, and then this is for what, for the column. So just like a matrix, the same thing happens in a data frame. So we you using 1 comma this can also do the same thing. But then I want to show you guys something that you can't even though we have not assigned names to the rows. So data frame we can mostly assign names to each of the rows. But if you go back to matrix, we can see that in matrix we were able to assign column names and then what, row names. So here we have row names and then here we have column names. But in data frame we don't mostly assign names to our rows. So we can't access the row name using any method. So we can only access the row name using the row index and then the column index. So um that is that. We could also check for we could also sort the values out or get a subset of a value in our data frame. So here, what we want to do is that we want to pick. Let me show you guys this one first. So we want to go to our data frame and then check the expression columns values that are greater than 3. So if you run this, you will see that if you come to our data frame here, okay, let me print this data frame here so that we can easily see what we have. So df here again. Okay, so in our data frame, you will see that we have um the what's the name? The expression values are 3.2, 4.8, and then what 2.5. Okay, so we want to find out, okay, which values are greater than 3. So if you look here, this is greater than 3, so it's returning true. This is greater than 3, so it's returning true. This is less than 3, so it's returning false. So if we want to filter our data set out, such that it should be able to return to us all gene expressions or the expression values that are more than 3, we can return, we can get that data frame out by just putting the logical value inside the data frame again. So we are just putting that expression inside the data frame, and then it's going to give us, it's going to return all the values that are, all the expression values that are greater than what 3. So that is mostly about this manipulation. Then we could also add um, 1 to each of the values, each of the expression values here. So you take the expression value, the expression column, and then we add 1 to the expression value again, and then you now reassign that back to this. So if we just do this, let me show you guys this. If we just do this, let's see what happens if we just do this. If we just do this, this is going to give us the, it's just going to tell us that okay, it has added 1 to all of them. But when we add 1 to it, we are adding that value back to our gene expression column. So this is going to return our data frame for us, but then it's going to be adding 1 to each of the values in our data frame. So that is mostly how this works. Let me run this on its own line. Okay. Okay. Yeah. Sorry for that. Yeah, we are here. Okay. So that now, if we should print our DF out, you would see that we'll be getting, oh, I have added to it. I think after running this, it has run so many times. So I run it here and then I've run it here again, so you can see that it has added one so many times to this. So this is just something that I wanted you guys to get from here. So we can do this to manipulate data frame. Now, yeah, I think we talked about this already. So this is out. Now let's look at some of the operations that we can do on the data frame. We can filter the data frame out. We can also summarize the data frame. We can also sort it out. We can add new rows and then new columns. There are so many things we can do to a data frame. So filtering out is what I did. I illustrated here. We filtered out all the values that are greater than 3 from this expression column. So that is what we used. So we filtered this out. Then we also did which one else? You can also sort your data frame, so we can just do sort gene expression and then it will just go and do that. So I don't want us to really worry much about, you guys can try this out. We can also add or remove columns, which we can also do that. But okay, yeah, before we do that, let me show you guys this, that we can also do We can also, okay, let me show you guys how to add the column. So now we want to add a column called log experiment. So log expression, meaning that we want to calculate the logarithm of the gene expression values in this data frame. So you have your df here, and then the new column you want to create. When we're looking at matrices, I show you guys that you want to add a value to a when we're looking at list, sorry, show you guys that you want to add a value to your list, just a new you want to create a new value in your list, just do this. So we want to create a new column called log experiment, and then we just add in this, or you can just say log experiment plus one or anything. Mm. So this is how we add a new column to a data frame. And then we can also do the summary. So when you type summary df, summary gives you okay, let me run this on its own line, and then we look at the differences. So let's take df again, and then you can see that we have what log experiment that is here. So we've added a new column to this. Then summary gives us an idea about our data frame. So it gives us, okay, we have sample ID. It is having three length of three. It is of the class character, the mode, which is character. I think I talked about mode last time to you guys. It also has a column called gene, the number of values it is having, and then it's also having a gene expression. The gene expression is having numbers. So here it is telling us a minimum value, first quartile, just like in data in pandas where you can do data.describe, where it's going to give you all of this. So this is telling us all of this information. So this is about data frames. Can data frames be named? Yes. Can it be ordered? Yes. We talk about this already. We can order data frames here by a given value. So we can order it by the expression value, and you can see that it is being ordered from least to highest here. So yeah, there's some joke here. Why did the data frame go to therapy? Because it had so many columns, an identity crisis. Don't worry if you don't understand this one. We also have some quiz questions here that you guys can just go through it and then check it out. Now, the yeah, so we have some videos here. Now, let me give you guys a summary of this before we get to the questions. So this is a summary of the data structures. Vectors, can they hold mixed data type? No. They can be ordered, they can be named. Mostly it is mostly a basic 1D data type. Lists can hold different data types, but we can't order it. Why? Because it is having different data types. We can also name it. Matrix, because it's having one data, it can only hold one type of data. It can be ordered and it can be named. Data frames, yes, we can it can hold one column data type. But one thing I want you guys to understand about data frame is that the columns can have the data type that we should have should be in the same column. So every column should have the same data type. So we can't, if we get back to this place, we can't have here, we can't have this column here. Where's our data frame? Yes, we can have this resistance having, let's say I put force, I put a quotation mark around this. So I put a quotation mark around this and I run this, and I run this again. I want you guys to see what happens. So you can see that now our resistance has been changed to what? To characters. Why? Because it has saying that this is what? A character data type. Previously, when we if we have yes true here and we run this and then we check our data type, because that it is telling us that the resistance column is logical. But if I put quotation here, making this this will now change the resistance column to what? To um, a character data type. So if you look here, this has changed to what? To a character data type. So the columns can only hold one data type, but the rows can have different data types. Like for instance, if you look at our row here, this row here, row S1 is having this character. So row one is having character, double, and then what's logical. So that is mostly about that. So that's, yeah, we are the summary here. So it can be named, it can be ordered, and then it is what, a tabular data type, just like what, spreadsheet. So this is about data types, and then the next thing that we would be going through is conditional loops. But since we are almost at the top of the hour, I want you guys to ask your questions. It could be questions on this, it could be questions on anything else that we are doing. So let me know if you guys have any questions. So let me stop sharing this and wait for questions. Guys, questions. Any questions? Hello, everyone. Hello, guys. Okay, on the chat, 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 on the chat. Okay. How to export DF from external file? Okay, nice question. Um, I didn't really, um, I didn't really want us to go there yet, cause we, you could just, what's the name? I'm working in Google Colab, okay? So in working in Google Colab, you can just import your data frame. What's the name? Let me check. Uh, okay, let me just try this. So share this. Can you guys see my screen still? I want to show you something. Hello. Can you guys see my screen? Hello. Okay, yes. Okay, great. Thank you. Um, um okay. So from here you open your Google Colab. Since I'm working in Google Colab, so you can import your data into this. So let's say, let me reduce this thing. Okay. So um, let me just say, do I have any data sets here? Okay, so okay. So let me copy this file path. I think Ken showed you guys this some time ago. I don't know if you guys, but where is the thing? Where should I? Okay, let me just create a cell here. Okay, and read CSV, and then this. So let's say this is what we have. So let's say we have I give a name of this. Let's say I'm having oh, sorry. Oh, okay, so let's say we're having house, and then we assign this to it, and then we print head of house here. I don't even know if this is what, yeah, so head of house here. So here, this is how you read a CSV file into Excel. And sorry, in R. So you have your CSV file, and then you know, so how do you export DF from external file? So this is an external file that I just brought in from my PC and then loaded it into Google Colab, and then there is a simple way to do it. That is, if you are using what's the name? If you are using R Studio, but if you are using Google Colab, this is how you can go about it. So you have read CSV. This is the default in R, but we have some libraries like the deep hey, deep pyr. Sorry, I forgot the name of the library that you can use. That can also be used in loading data frames, different type of data frame. When we get there, I didn't really touch on this because maybe I thought maybe when we get to that side, we'll talk more about that when we get there. Yeah, so this is how you read an external file into a data frame into from an external file. So the head here is just in R, head is used to show the first six. In Python, it is used to show the first five. So you have head here, then you put your data frame into it. So this is how you read a data frame in R from an external file. So I hope that answers your question, Dema. Yeah, Dema, was that your question? Okay, she's typing. Yeah, thank you. You are welcome. Please, the group will be able to communicate. So my phone is already getting. Oh, sorry. She was. I don't know if you are in the WhatsApp group. Ken, I don't know. Maybe or you can. Is he there or he's gone? I think he's gone. Yeah. So guys, your questions. Or there is no questions, so that we call it a night. No more questions. No more questions. Okay. I'm still waiting for your questions. So if there is no question, then Ken, I think we can wrap up for today, right? Ken, are you there? Okay, guys. Um. Okay. I think then let's wrap up for today. So thank you guys so much for joining. We will still make the recording available on YouTube soon for you guys to go through. If you have any questions, any confusions, anything to share, you can just hit us up in a group, and then would be able to help you out. If
Me, sorry, Richard.
yeah,
Okay, I'm very sorry. I just got back home and was kind of very distracted. So thank you very much for the class. I don't know if you can draw my attention to why me.
why?
Okay, was it me you were talking to that
Yeah,
time?
yeah. I was asking you, like I said that we are done. If you have anything to add or anything to subtract before we
Okay, no, no, no. I don't really have anything for today.
okay,
So
okay,
thank you very much.
okay.
Thank you very much, and to those that have been consistent with the class, definitely you reap the reward. The facilitator thanks to the students. So thank you all, and they have a wonderful night rest.
Yeah. So bye, guys.